Dragon Prince dinosaur discovery is changing how scientists understand T-Rex. Scientists have identified a previously unknown 86 million year old dinosaur species that fills an early gap in the fossil record of tyrannosaurs, revealing how they evolved to become massive apex predators. Researchers analyzing the species' remains have named it Conkylu mongoliensis, which translates to Dragon Prince of Mongolia, because it was small compared with its much larger relatives such as Tyrannosaurus rex, whose name means the tyrant lizard king. The newly identified dinosaur was the closest known ancestor of tyrannosaurs and likely served as a transitional species from earlier tyrannosauroid species, according to the findings published Wednesday in the journal Nature. Based on a re-examination of two partial skeletons uncovered in Mongolia's Gobi Desert in 1972 and 1973, the new study suggests that three big migrations between Asia and North America led tyrannosauroids to diversify and eventually reach a gargantuan size in the late Cretaceous period before going extinct 66 million years ago. This discovery of Conkylu forced us to look at the tyrannosaur family tree in a very different light, said study co-author Darla Zelenitsky, associate professor within the Department of Earth, Energy, and Environment at the University of Calgary, in an email. Before this, there was a lot of confusion about who was related to who when it came to tyrannosaur species. What started as the discovery of a new species ended up with us rewriting the family history of tyrannosaurs. Multiple migrations over millions of years. Tyrannosaurs, known scientifically as Utyrannosaurians, bring to mind hulking dinosaurs like Tyrannosaurus rex and Tarbosaurus, which weighed multiple metric tons and could take down equally large prey. With short arms and massive heads, they walked on two legs and boasted sharp teeth, Zelenitsky said. But tyrannosaurs didn't start out that way. They evolved from smaller dinosaurs before dominating the landscapes of North America and Asia between 85 million and 66 million years ago, the researchers said. While Tarbosaurus, an ancestor of T-Rex, clocked in at between 3,000 and 6,000 kilograms, 6,613 pounds and 13,227 pounds. The fleet-footed Conkylu mongoliensis likely weighed only around 750 kilograms, 1,653 pounds, spanned just 2 meters, 6.5 feet at the hips, and 4 meters 13 feet in length, according to the study authors. Comparing the two dinosaurs would be like putting a horse next to an elephant. Conkylu would have reached T-Rex's thigh in height, Zelenitsky said. Conkylu was almost a tyrannosaur, but not quite, Zelenitsky said. The snout bone was hollow rather than solid, and the bones around the eye didn't have all the horns and bumps seen in T-Rex or other tyrannosaurs. Conkylu mongoliensis, or a closely related ancestor species, likely migrated from Asia to North America across a land bridge between Alaska and Siberia that connected the continents 85 million years ago, Zelenitsky said. Because of this migrant species, we now know that tyrannosaurs actually evolved first on the North American continent and remained there exclusively over the next several million years, she said. As the many tyrannosaur species evolved on the continent, they became larger and larger. Due to the poor fossil record, it's unclear what transpired in Asia between 80 million to 85 million years ago, she added. While some Conkylu may have remained in Asia, they were likely replaced later on by larger tyrannosaurs 79 million years ago. Meanwhile, another tyrannosaur species crossed the land bridge back to Asia 78 million years ago, resulting in the evolution of two related, but very different subgroups of tyrannosaurs, Zelenitsky said. One was a gigantic, deep-snouted species, while the other, known as Alioramans, was slender and small. These smaller dinosaurs have been dubbed Pinocchio rexes for their long, shallow snouts. Both types of tyrannosaurs were able to live in Asia and not compete with each other because the larger dinosaurs were top predators, while Alioramans were mid-level predators going after smaller prey. Think cheetahs or jackals in African ecosystems today, Zelenitsky said. Because of their small size, Alioramans were long thought to be primitive tyrannosaurs, but we novelly show Alioramans' uniquely evolved smallness, as they had miniaturized their bodies within a part of the Tyrannosaur family tree that were all otherwise giants, Selenitzky said. One more migration happened as tyrannosaurs continued to evolve, and a gigantic tyrannosaur species crossed back into North America 68 million years ago, resulting in Tyrannosaurus rex, Selenitzky said. The success and diversity of tyrannosaurs is thanks to a few migrations between the two continents, starting with Conculu, she said. Tyrannosaurs were in the right place at the right time. They were able to take advantage of moving between continents, likely encountering open niche spaces, and quickly evolving to become large, efficient killing machines. Revisiting a decades-old find, the new findings support previous research suggesting that Tyrannosaurus rex's direct ancestor originated in Asia and migrated to North America via a land bridge, and underscore the importance of Asia in the evolutionary success of the Tyrannosaur family, said Cassius Morrison, a doctoral student of paleontology at University College London. Morrison was not involved in the new research. The new species provides essential data and information in part of the family tree with few species, helping us to understand the evolutionary transition of tyrannosaurs from small, medium predators to large apex predators, Morrison wrote in an email. The study also shows that the Alioramini group, once considered distant relatives, were very close cousins of T. rex. What makes the fossils of the new species so crucial is their age, 20 million years older than T. rex, said Steve Brusat, professor and personal chair of paleontology and evolution at the University of Edinburgh. Brusat was not involved in the new study. There are so few fossils from this time, and that is why these scientists describe it as murky, Brusat said. It has been a frustrating gap in the record, like if you suspected something really important happened in your family history at a certain time, like a marriage that started a new branch of the family or immigration to a new country, but you had no records to document it. The Tyrannosaur family tree was shaped by migration, just like so many of our human families, with only fragments of fossils available. It's been difficult to understand the variation of tyrannosaurs as they evolved, said Thomas Carr, associate professor of biology at Carthage College in Wisconsin and director of the Carthage Institute of Paleontology. Carr was not involved in the new research, but the new study sheds light on the dinosaurs' diversity and clarifies which ones existed when and how they overlapped with one another, he said. More samples from the fossil record will provide additional clarity, but the new work illustrates the importance of re-examining fossils collected earlier. We know so much more about tyrannosaurs now, Carr said. A lot of these historical specimens are definitely worth their weight in gold for a second look. When the fossils were collected half a century ago, they were only briefly described at the time, Brusat said. So many of us in the paleontology community knew that these Mongolian fossils were lurking in museum drawers, waiting to be studied properly, and apt to tell their own important part of the tyrannosaur story, he said. It's almost like there was a non-disclosure agreement surrounding these fossils, and it's now expired, and they can come out and tell their story.